Okay. All right. So the attendance tracking is on. Share the screen off. All right. Everything is done. Let me share my screen. Okay, before directly jumping into the coding, so we'll just learn, we'll just do a quick recap on what exactly was Solidity, how smart contracts actually work, and why do we need smart contract on Ethereum-based chains. Okay, I'll just open up my drawing board for that. Okay, yep. Right. So the first thing is, so remember on the first day we were talking about this whole thing, right? Like the okay, guys. One thing is I want to tell you guys I'm not in my usual room today, so I don't have proper lighting setup or audio setup right now. So my voice might be a bit, what do you say, distorted or something. So just bear with me for that. Okay. So okay, next thing is, so remember in the first class, we did go through all this blockchain stuff, right? Like we did learn about how it is decentralized, how the data are immutable. I mean, the data are like once you add data, you cannot modify that, right? So we did look into all of those stuff. So today, we'll just see how smart contracts actually work on the chain. Okay, so let's say this is your smart contract. Oh, I think I've zoomed in a lot. Let me zoom out a bit. Right. Okay, let's say this is a smart contract that has some instructions here. Okay, that has some instructions, and then you drop this on your blockchain. Okay, so let's say these are a blockchain here, and then we drop this on a blockchain. We deploy it to the blockchain. Now what happens is this smart contract will have these instructions, right? So here there are two parties. One party is the owner. I don't even have my mouse, so the drawing might not be good. Okay, so the first party is owner. So owner is the one who deploys the contract. Okay, so if I'm deploying the contract, I'll be the owner. If you deploy, you will be the owner. Okay, and the next party is the users. Okay, there are two parties, owner and user, and you can add additional party here, that is admins. So if you want you can also add additional parties here, that is admin. We will actually see all these parties tomorrow when we deploy our NFT contract, but for now, let's just drop this admin part. We'll just think you user owner and the user part. Okay, so owner is the one who deploys the contract, user is the one who interacts with the contract. Okay, so when I the owner will define all these instructions, right? The user cannot violate them. Okay, the user cannot violate them. So let's say we are deploying a contract for real estate. Okay, let's say we're deploying a contract for real estate, and I'm the owner who deployed it. So I have some lands. Okay, I have some lands. I have a layout. I have some lands inside the layout, and you come there. Okay, person A comes there, and then he buys a plot. Okay, he buys a land. The land name is Project A, PA. Okay, the person A buys PA, and this PA will be minted on the blockchain. Okay, so I'll just upload all the documents associated with the PA in my smart contract that is stored in the blockchain. Okay, now what happens if person B comes here and tries to claim that PA who is owned by him? Okay, it tries to query. Let's say he tries to query all the documents that of project PA. The smart contract will reject it. It will invalidate it. The reason is whenever the request comes in, smart contract checks for all the headers. Okay, the header is here. The person B is calling the function to retrieve all the details associated with the project A, which is completely not owned by him, right? So the smart contract rejects it directly. Okay, smart contracts is a computer program. Obviously, it follows all the instructions. So the owner here define the instructions that, so whatever the project here, if it is being queried by its owner, return it or else reject it. So it rejects it. So by this way, it creates a trust, right? What if this was some kind of person? And we know how this many things work, right? So if this was a normal person, then this person B could have bribed this person and got all the information of project A, and he could do some forgery on the documents, and he could have claimed it its own. But on blockchain, that doesn't happen because smart contracts reject all the requests. So this increases trustworthy of the of the chain as well and the concept as well. Okay, so now how does this data, the PA, where does this data, the PA, get stored? So we know that owner will upload, like this owner, right? I own this land, right? I sold this PA to person A, and I uploaded all the documents related to PA to my chain. But where does this data actually get stored? So we need that information, right? We know smart contracts will help us to write functions, write instructions and everything. But where exactly is this data stored? The documents related to this PA, where exactly is that stored? So that is stored inside EVM. Wait, EVM. Okay, EVM stands for Ethereum Virtual Machine. So this EVM is the one that executes your requests and everything, all your smart contracts and everything. So smart contracts will be holding this mapping variables and everything. We will actually look into that today. How we store multiple relation data, how we store a single data and everything. So you will be storing that inside this one. There was a chat. What if someone gets access to the user? I'll address that. I'll address that. Okay, so that's how smart contracts actually store them. So you'll have some data types. Okay, you will have some data types on Solidity. Using that data types, you store all the data. Okay, and that data is stored on EVM. And for that, I mean, that's data that's stored on EVM. We call it as state. Okay, we call it as state. Okay, so whenever the data is changed, we don't say data is changed. We say there is a new state available, or there is a new state change. That's what we say. Okay, so this is how the whole smart contracts works on brief. Okay, now coming to this question here. There are a few questions, I guess. Yeah. What if someone gets access to the user itself? That's a good question. What if B gets access to A and tries to query the project A details as pretending to be the person A? What about this? So the only way this is possible is by sharing your private key. Okay. So here, when I say owner or when I say user, we're not referring to the person here. Okay. When I say owner, I'm not referring to myself here. I'm referring to my wallet address. Okay. My wallet address. And similarly, when we say user, we're not referring to the person, we're referring to the wallet address of that user. Okay, we will see what is wallet address here when we jump into the code. But just remember, wallet address is something like this. Okay, this is MetaMask and this is my wallet address. Okay, see, it will be something like this. Something like this. Okay, so we are referring to something like this. Okay, if user A is querying, we check the wallet address of the user. If the PA is associated with that wallet address, only then we'll return it, or else we reject it. But how can B get access to that wallet key? Right? How can B get access to that wallet address? So that's actually possible. How is that? If person A intentionally gives his private key, okay, to person B, that's possible. If person A accidentally reveals his private key, or if person B got access to person A's system somehow and took his private key. In these scenarios, if the private key is compromised, then there is nothing we can do, because it's like, one of the security thing. It's not the fault of the smart contract, but it's the fault of the user, right? That's how B can get access here. If the B gets the private key of A, then there's nothing we can do. Okay. So is all the doubts clear, guys? I hope that made sense for you guys. Okay. All right. Now jumping into the code. So before jumping in, I'll have 1 minute. Give you 1 minute. If you guys have any questions, you can drop on the chat right now, because I don't want to rush in this particular concept. So if there's anything, you can ping in the chat right now. No questions? How can A will be associated with project A? I just told you, right? A bought the land, so that's why he was associated with project A. Okay. All right then, cool. So let's get started with the coding then. Okay, now jumping into code. So remember, on the first day I told you about hard hat, truffle, and everything. So these are the tools that lets you, build, debug, and debug, and deploy smart contracts. But these tools are good when you're building a project. But if since you guys are getting started with Solidity, it's better if you have some visual representation of what happens and everything, right? So for that, today we'll be using Remix. Tomorrow, let's use this one. What do you say? What was that? Sorry, Hard Hat. Tomorrow we'll use Hard Hat, but today we'll use Remix. Okay, so this Google Remix IDE. Okay, Google Remix IDE, and you get this Remix project or Remix Ethereum IDE. Just click on that. Okay, and you'll get something like this. Just open up, start coding online here. Okay, so this will get you this type of UI here. Okay, I have some contracts already here, so I'll just create a new workspace. I'm gonna say this Duolearn workspace. Okay, so you'll get some files automatically here, but don't worry about all these files here. You can clearly ignore that. Just go inside contracts. You'll also have some basic contract setup already. You can experiment with that, but we'll be creating a new one. So here we will say cons. We'll just follow the same naming structure here. So since this is the fourth contract, I'm gonna say four. Learn.sol. So since we're learning it, we'll just say learn.sol. Again, keep a note, guys. Whenever you're declaring a Solidity file, the extension should be .sol. Okay. Okay. Now we are here. Again, why we're using this one is because this is only for today. Okay. Tomorrow we'll use hard when we write NFT contract. But for today, since you guys are getting started, I'll be showing you like how compiling works, how deployment works, how you can actually call methods visually. Okay. 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 Now I'm gonna just open up learn.sol on my writing pad here. I'm gonna zoom in a little bit. This is good. Guys, just 1 second. 1 second. All right, there are some questions here. Why can't we use Remix for projects? Because Remix, I'll tell you that later. Okay, at the end, after we built everything, I'm going to show you the difference between why we use RDAT and why we don't use Remix for everything. Okay, and coming to the what are those inbuilt contracts? It's not inbuilt contracts, just some getting starter contracts that Remix provide you. So if you're new, it will help you to play around with it and everything. That's why. Okay. All right, coming back to this one. So we'll say the first thing that we have to do is you have to define the Solidity version. Okay, because it's very important in Solidity ecosystem that you define a version. All right. So what we'll do is we'll say pragma. This is the keywords we use to define the Solidity version with the Solidity, and we'll say the latest version 8.0. Okay, we'll go with latest version 8.0. 8.0 is not the latest, but it is actually the series of the latest version. Okay. Right. Now we'll define the contract. So we start the contract by defining contract and then the contract name. So I'm going to say learn. Okay. And then I'm going to open curly braces here. All right. And then we'll just write a simple function right now that returns hello world. Okay. So we'll define function. Okay. And then we'll say greet. Okay. Return hello devs. And we got some error here, right? You can see we are getting some errors here. The first error is there is no SPDX license identifier provided. That's the first issue, right? And then it says, what do you say? This one. No, did you mean public? There's no visibility specified. And coming back to here, it says different number of argument in return statement. So what happening here is Solidity expects you to define every single thing. Okay, it's very strict. It doesn't accept something like this. Okay, I mean you can see that it's bare minimum. It doesn't accept something like this. So it expects you to define every single thing. Solidity. Okay, I made a typo mistake here. Right. Okay. Right. Now let's do one thing. So let's add this. So since we're not doing any write operation there, we're not updating anything, right? We're just returning the string here. So I'm gonna name this as pure. Okay, the reason why I'm naming this pure is no matter how many times you call this greet function, it returns the same value, right? So it's pure function. Okay, it's not updating anything. It's not even depending on any values outside the function. It's just returning same value. So we'll call it pure. Okay, and then this is the public function. So we'll define public. Why public is it should be accessible outside to the user. So user should be able to access this function. Okay. Other than this, there are things like private, protected, and everything. You know, in Java, you guys have this, right? Public, private, and everything. Same thing. Okay. For here, I'm going to say public. And then I'm returning a string here, right? So I have to define the return type as well. So I'm going to say returns string memory. Okay. Again, guys, this is return singular. It is returns plural. Okay. Keep in mind, though, there is S here. There's no S here. Right. So now we can see everything is gone. All the issue is gone. But there is a warning here. It says SPDX license identified not found. So every time you write a contract, Solidity expects you to provide license for that. Okay. There are open source license, right? Like MIT, Apache, some Apache license or something like that. So it expects you to define a license. I mean, it's completely optional. But if you're writing a contract for any of your application, and if it's an open source application, you can define MIT. If it's a private application, you can define a associated license over there. Okay, the way you define a license is something like this. Let me show you. Storage, yeah, something like this. Okay, so this particular contract follows GPL 3.0 license, so you can define something like this. Okay, all right. Coming back to our contract here. Okay, so now we just finished writing the contract here. So we have a simple function that returns hello world, and that's a pure function. Because why? Because the function returns the same value every single time when you call it, and it is not dependent on any other values, right? So there is no other value that's depending on it. So it's a pure function, and then it's a public, so user can access it, and it returns a string. Okay, now let's compile it. So to compile it, you can see we have this Solidity icon, right? So you have to click on the third icon, and then you have to select the compiler version. So our version is 8.0. Make sure you select 8.0 here. I mean, it will auto detect it, but if it's not, just select it. Okay, and then make sure you're compiling the right file name here. Our file name is learn.sol, so make sure the file name is right. Okay, we click on compile. Okay, now it is compiled. It says one warning. See the same thing. Warning: XPDX license identified not provided. Okay. I mean, if you want, maybe we can provide it. There is no issues with that. We'll just copy that, come up here, paste it, and then we'll change it to MIT. Okay, now we can see there is no warning, no error, or nothing. So everything is properly compiled. Okay, now to deploy this contract, right? Now to interact with it, we have to deploy it. So click on the fourth link here. Okay, click on the fourth icon. Okay, fourth icon here. Then it will ask environment. So if you click on this, you can see there are multiple environments here, right? Remix VM London, Remix VM Berlin, MetaMask injected provider, hardware provider, Ganache provider, and everything. So these are the if you are using, I mean, tomorrow will be. I mean, we can use MetaMask right now. I'll show you the MetaMask way of deploying as well. But MX VM and Remix VM Berlin are nothing but EVM. So these are all the environments. Okay, EVMs basically to execute this chain. Okay, so here we'll select Remix VM London for now. Then we'll also at the end we'll deploy it through MetaMask. Okay, to Polygon chain. All right, now when you select Remix VM, you can see we have around 10 accounts. So this will give you the accounts as well. So remember the wallet address I told you here, this one. So it is similar to that. If I copy paste this, you can see, right? Same thing. Okay, it gives us around 10. It will generate around 10 wallet address and with 100 ethers balance. Okay, it will have 100 ethers inside it. It is a balance. Remember the gas fee that we talked on first class. So we need balance to pay for gas and everything. Okay, and now we select the contract. It says learn because the contract name is learn here. So we are deploying a learn contract, and then we click on deploy. So you can see we got the logs. It was properly deployed. And then here in the deployed contracts, we'll have everything. So I'll expand this by clicking on this arrow icon. So you can see we have this greet function, right? You can see, right? If I click on this function, I will call that function. So this is actually visual way of interacting with the smart contract. That's why I choose Remix for now, because you'll not only be able to deploy it, you'll be able to interact with it visually. Okay, this is a very amazing, I mean, the best way to learn smart contract development and getting started. Okay, so you can see whenever I click on this, I ran the function twice right now, and I got the same result. Even if I click on it, I'll run it again. You can see I got the same result. Let's change it. Let's change hello devs to hello world. Okay, now let me save it. Let me compile it. And if I click on greet, I don't get the I don't actually get the hello world. I get hello devs. Why? Can anybody answer why we're not getting hello world, but we're getting hello devs? Anybody? Is it compulsory to define data types? Yes, we did. It's very compulsory to define types as well. Because we didn't compile. We did compile. I'll compile it again if you want. See, I compile it again. I did compile it. And if I click on greet again, I get the same value. Can anyone tell me why we're getting the same value and not hello world, but we're getting hello devs? Why? It is stored in memory? Nope. No, it's not stored in memory. Come on, guys. Remember the first class that we said? Immutability. Come on. We're calling the old contract. Exactly. Did you Google or something? Exactly. The thing is, remember the first thing that I remember on the first day that I said that once you deploy a contract, I think someone asked me this question like, what if I deploy a contract to mainnet and then if I mess things up, if I make a mistake, what to do? Someone asked this question. At that moment, I told you guys that once you deploy a contract and if you made a mistake, there is no way of updating the contract again. You have to deploy a new one, right? So we deployed the contract and then we made a change to our contract, right? Then we made a change. We changed something here. So there is no way that this contract will get updated. So the only way is we have to deploy a new one. So I deploy a new one, and here's the new one. Wait, which one is the new one? I think this one. So if I click on greet now we can see we get hello world. Let's call the old contract, we get hello devs. For new contract, we get hello world. Okay. So this is how the chain works actually. So once you push to the chain, that's permanent. That's it. You cannot update it no matter what. Okay, it's immutable. Okay. All right, now let's delete all of these deployments and let's go back to our contract. Let's make some updates to that. Okay, now let's learn some basic data structures here, very basic data structures that you already know, like, string, numbers, boolean, and everything. So in Solidity, to define a string, you say string, str, some value, something like this. Okay. To define a number, you use event num 1 to 3. Okay. To define a boolean, we use bool. Now is raining. So that's it. Okay, there are some more what do you say, data structures like arrays and everything. So I mean, we don't use arrays much. We use mappings a lot. So we'll keep it aside for now. Okay, let's jump into the mapping. Mapping is very important for you guys. So I mean, these basic structures are something that you guys can do self-learning on that, right? Arrays and everything. So we'll just learn about the important concepts that's required for you to understand the standard contracts like ERC20 and everything. Okay, the first very much important data structure on Solidity, like it's literally used everywhere. Okay, it's literally used everywhere. That is mapping. Okay, mapping. Mapping is something that is used everywhere. Like whatever the contract you see, it will be used. I mean, this is how we actually store data. Okay, so we say mapping, and we have to define what data structures are we trying to map here. So let's say we're building a to-do list here. Okay, a simple to-do list. So we'll be mapping a counter that is a type of integer with a type of value that is string. Okay, so we'll be mapping a event that is integer, the number, the counter number, and then the task string. Okay, so that is a string, and then we'll store that in to-dos. Okay, so what is mapping? So mapping is nothing but you keep track of two data structures, okay, or two values. One is the key and one is the value. Okay, so it is similar to storing array of objects or something like that. So it will be like key and then value, key and then value. Okay, you'll be storing something like this: key value, key value, key value. So let's say this is key 0, this is 1 and 2. Let's say you need the value associated with key 1. So you can directly call 1 and the value will be returned. It's something like that. Okay, so remember in this example, I told you about this project A, right? The owner has some land. He'll be giving out to like A purchased the land, project A, and then owner updated all the data in the chain. So how we'll be storing the land data? Using mapping. So he might map instead of event, he might map address. Okay. Oh, I forgot about the address as well. I'll tell you what is address. Okay. He might map address of the user to the what do you say? Maybe he can define a structure or something to the project A. So let's say we'll have event for the project. He'll define project A, something like this. He'll map something like this. Okay. So now this works is, so he can map. So let's say this is the user address, and then this will be map for project A. Let's say project A is ID 1, and similarly, another user comes in, another user buys the project. So let's say the another user address is this one. Okay, and then he will map the project 2 to this address. So whenever if the person 1 as a person A comes and wants to be get the details of their project, so the contract will check for this address. If it is matching, then it will return the value of 1. Okay, the project 1. Again, if this user comes and query the project, it will return the project 2. If other user comes and query for 1 or 2, it will reject it because address don't match. Okay, it will be mapping is something like this. Okay, mapping two data structures. It is kind of tricky, but I think these things these are common data structures in other languages as well. So I think this won't become very hard hard thing for you guys to grasp. But this is really important, guys. Keep an eye on this one because mapping is literally used every single in every single contract, almost every single contract. Okay, now let's come back to event and then string for our to-dos. Right. Now instead of function greet, we'll say function add to do. Okay, and then we accept a string. It's a task. Okay, and then this will be public functions. I'm going to say public. Okay, and then we have to make this as okay. This is right function, and then this will return a boolean. So we'll say true or false, or instead of boolean, let's return a event. Let's return the ID of that task. Okay, now we need an ID, right? We need to keep track of the number as well. We need an ID. So the best thing is to add a counter. So we'll define a counter. I'm going to say event count. For now, I'll keep 0 or 1. Let's start with 1. Okay, so now what I'll do is I'm going to say to-dos of count equals task. Okay, so whatever the task we get from this to-do function, we say count. So this will be sending it to the event will be 1 right now. The string will be the task that the user is sending us. Okay, and then we'll increment the count. We'll increment the count. Notice all this syntax here. Isn't it similar to other programming languages, right? And then we have to return the count here. Oh wait, this might actually not work. This will return this one, right? This will return the updated count. So let's do one thing. Let me update the counter here on top, and then I'll update the task. I keep this one as 0. Okay. Okay, so we'll return the count here, and then we'll return the updated count. Okay. This is actually throwing some issues. Why? Oh yes, you have to store this in memory. Right. Now everything is gone. Okay, so now people can come here, send the task. They can send the string task. Let's say go purchase groceries or something, and then we'll increment the count. That is the ID, and then we store that task in the mapping. Okay, and now let's write a function to get the task. Let's write a function to get the task. So if they get task by ID, let's say public. We'll accept ID here, event ID, and then we say returns string. String. Right. Now what we do is we say return to-dos of ID. That's all. This will return it. Okay, and then since we're not modifying anything, right? Here we're actually modifying the mapping here. So it's like updating the data. Okay, but here we're not updating anything, right? We're just reading it. For that, we say view. Okay, so we say view because we're not updating anything, we're just reading it. Okay, this has a really big potential. I mean, this is really important because when you specify view, you won't be paying gas because you're not writing anything to the blockchain, right? You're just reading it. So there won't be any gas. If you don't specify view, then you'll be paying gas. Okay, view and pure function doesn't have any gas. Okay, right. So it should be string memory. Okay, Please keep in mind this. Keep in mind, guys. So I mean, compiler will warn you to add a view over there, but just keep in mind that whenever you have view, it's no gas. It's gasless. Okay, you won't be paying gas because you'll be just reading the data, right? And then we'll have one more function to clear to dos. Okay, let's say clear to dos, and this will be public, and then this will return a boolean. Okay, and then we'll accept ID as well. ID of the asset we need to clear. Okay, and we'll say delete to dos of ID and return true. Okay. Right. So we have all the other three functions. We have a simple mapping to store all the to dos. We have to do get task by ID and clear to do. And notice one thing: we're not writing any function that gets all the tasks or a clear function that clears all the tasks here, right? The thing is, you cannot clear every data from mapping at once. Okay, we cannot say like to-dos dot delete everything or delete all. There is no such kind of thing in Solidity. So Solidity expects you to clear them one by one. So if you want to clear everything, you basically have to loop over it, clear it one by one. Okay, so because it helps us to create. This is actually for security concerns they have built it this way. Okay, usually if you want to get all the tasks at once of a particular user, we use structure to do it. Okay, so we map it via address and then we use structure to store everything. But since this is a very simple to-do list, it's fine. Okay, now let's see in the contract. Let's deploy this contract and check how it works. So we'll deploy the contract. And notice we didn't compile it because it auto compiles it. I've enabled this auto compiler, so it auto compiles it. Okay, so now let's deploy this. And then if it's deployed, yep, it is deployed. And now we can see we have three functions, right? We have three functions. And notice the color of the functions. So these two are in orange color. And this one is in like a, like I don't know what color is that, but it's in different color, right? So the thing is, orange colors are one that you pay gas. Okay, they are write functions. Okay, where they modify something on the date, something on the chain. They modify the state. Okay, these like light blue ones are something that's a read function. They won't modify anything, and it's a gas class. Okay, so now let's add. Let's try to add a like a to do. So I'm gonna say this is compile this contract. You can see it was added. Oh, wait. What did I do? Okay, I just, okay, I did came back. So let me just try to compile it and do it again. All right, we're not getting any return data here. It's not showing us any return data, but we're able to add two data here. Let's try to get it. So I'm going to say 1. You can see we got compile this contract. Let's say 2. Did we get it? Yes, we got it. We got it. Compile this contract. Let's add another to do. Let's say go to shop. And that you can see we did it. If I come back, if I go to 3, you can see I got the same data. Okay. And now we can see where are we paying the gas here, right? I told you like whenever you try this, you pay gas, but where are we paying it? So if you scroll up, you can see it was 100 before, right? Now we can see it is around 9.999 something, right? So this is where this is actually paying gas for you right now. For every transaction, this is paying gas. I mean, gas will be very minimal, so you won't see actually a lot of difference here, but it's very minimal, but you are actually paying it. Okay. So now let's try to clear some to-dos. So I'm going to clear to-do 3. I'm going to click on transact. It is done. Now let's try to query this one. Let's try to call ID 3. So it says it should return some error for us, or it should return empty. See, it is empty. So it's basically not available. Okay, cool. Now let's do one thing. Let's add a condition. Okay, let's add a condition where only the owner, right? Only the owner is able to delete a to-do and nobody else. Let's add that condition. Okay, remember if else statement here. So here we'll be adding a modifier. Okay, so we'll define a modifier. Okay, we define a modifier. So and we'll say only owner Okay, we'll say only owner. So only owner should be able to do something. So wherever you call this modifier, it will be called by only owners. Okay, I'm gonna say require msg.sender equals owner or else return. And then I'm gonna add a error message as well. We'll say not an owner. So what is this statement? There was so many things here, right? So first thing is modifier is a keyword. Okay, so these modifiers will be attached along with these functions. Okay, we'll be attaching them to. It's like a middleware. Remember in Express, you guys have this middleware, right? Not only Express, in many backends and everything, you guys have this middleware, right? That does something before calling the main function. That's what this modifier do. Okay, this will take care of all the jobs that you provide here before calling the main function. Okay, so here we're checking whether the msg.sender is someone who calls the contract. Okay, so right now here this address is calling the contract, right? This address is the msg.sender. If I call from this will be the msg.sender, message.sender. Okay, so whoever calls the contract, that will be msg.sender here. And then we're checking if it is equal to owner, but there is no way we define the owner here, right? There is no owner here. Where will we define owner? Nowhere. So let's define it. So it will be address owner. So what is this address here? Address is a data type to hold Ethereum address. So remember the address that I told you here, the wallet address, this one. This is the address, right? This is the Ethereum based address, right? So this data type is designed to store and process this type of addresses. Okay. So right now we're checking whether message of sender, even message of sender is a type of address. Okay, we're checking if it is equal to owner. What if I change this to string? This will shout now. See, it is yelling at me that operator not compatible with types. Okay, so let's message it to address. Okay, now what we're saying is we are attaching this only owner modifier. We'll be attaching this only owner modifier, this clear to do's function. Okay, it will check whether the message of sender is equal to owner. Okay, if it is not an owner, it will just throw a message called not an owner. Okay, if it is, then it will go. It will just redirect to the function. Remember in Express, whenever one middleware is done, we call next function, right? So that is similar to here. Okay, so whenever this modifier is done executing it, if everything works out well, then the underscore will transfer the mechanism to the next middleware or next modifier or to the function itself. Okay, so we'll call this only owner to clear to do's. Okay, something like this. That's all. There is no complex setup. That's okay. Now this is the owner that but there is no owner value here, right? The owner value is empty. So first we'll hard code it and then we'll see how to dynamically assign it. So I'm gonna hard code it. Okay, see, I'm not even adding double quotes here. If I add double quotes, it will be a string. I'm directly adding the address. Okay, now, so this address is the owner. Let's change the address. Let's change the account and come back and try to delete one. Let's try to delete number 2. I click on clear to do's. It will actually work because I have to redeploy the contract. I forgot that because the contract was updated, right? So let's select the address 1 again. Okay, let's deploy the contract with that. Wait. I think I messed up again. I don't know why. Whenever I try to use my mouse pad, I just come back. I just go back to I refresh the page or something. So let me select this one, contract, deploy. Right. So let me select the address 2 now or address 3. Okay. Let's try to. Oh, no, wait. Yeah, let's try to add some to dos here. So let's try to add. This is a test. Okay. This is a test 2. Again, guys, we're checking only for owner, not the user who actually added the task here, right? So, okay, I messed up again. Now, let's try to get an ID. Let's try to get the task 1. Okay, we're getting something. Now, let's try to clear the task 1. So, the owner of the contract is the account 1, right? Account 1. But right now, I'm in account 3. So, you can see I'm in account 3, right? Now let's try to clear the contract. Let's clear the to do here. Let's try to clear to do one. If I click on this, you can see it throws an error. Error, right? Error. EVM error revert. So it says revert. The transaction has been reverted to the initial state. So what was the first state? I mean, not initial state means the first state, to the previous state. Okay. The reason provided by the contract was not an owner. So where did we define this not an owner? In the contract. Remember here, not an owner. So this modifier threw an error saying that it was not an owner because the owner didn't match. Now let's try to switch back to the account one, okay, the owner of the contract, and then try to clear the to-dos. I click on clear. Now we can see it succeeded. Okay, so we cleared one. So now let's get one, token ID one. You can see it is empty. So it was cleared. Okay, so this is how you can actually manage modifiers. So this helps you. I mean, we'll be using this a lot in NFT contract because NFT contracts will have admins, will have owners, will have users, people who owns the NFTs and everything, right? You'll be using this only owners a lot. Okay, only owners and other types of modifiers as well. But this is the base meaning of modifier. This is how we use the modifier. Okay, so now let's see. Right now we hard coded the owner. Now let's see how to dynamically assign the owner. Okay, so for that, I'm going to just remove the value here. Remember, in class-based components, so remove the components in class. Whenever you instantiate a class, which is the first method that executes? You guys know OOPS concepts, right? So in class, which is the first method that executes, or that is called? Which is the first method that is called or executes? Any idea? In class, which is the first method or the function that is executed? Constructor. Remember? So that's what we'll be doing. Let's say constructor. Okay. Again, this constructor will only be called at once. So when this will be called during the deployment time. So when you deploy the contract, right? This constructor will be called only once, only during deployment time. So remember I told you this message of sender will contain the wallet address of the caller, right? Whoever is calling the contract or doing some operation of the contract will the message of sender will have their wallet address. So if I'm deploying the contract, then this msg.sender will have my address. Since I'm deploying the contract here, I'm the owner, so I can use this, right? So here inside the constructor, I'm going to say owner equals msg.sender. Okay. Again, guys, this constructor will run only once. That too when during deployment. Okay. If you call add to do, this constructor won't run. It won't run again. So if I'm the owner, right, I'm deploying the contract means I'm the owner, right? So if I'm the owner, if I'm deploying the contract, then this message sender will contain my wallet address, and since I'm the owner, we'll be assigning here. Okay. Now let's try this. Okay, now let's try this. Let's delete the deployments. Let's select account one. Let's deploy. Okay, this is deployed. So now let's add some to-dos. Let's say hello, add to-do. Let's say hola, add to-do. Right. Now let's try to delete the hello one, the first one. Let's say delete the ID one. If I click on clear to-dos, you can say it succeeded. Let's try to change the account and delete the second one. I change it to 3. I'm going to delete the second one. It won't work. Not an owner. Okay, because account one, since the account one was the one who deployed the contract, that was noted as the owner of the contract. Okay. All right. Now, so these are all the basic things that you need on the contract while learning the contract, the compiling, the deployment, the modifiers, and everything. Okay. But there are many advanced things as well. So just the best way to learn all these things is with Solidity documentation. Actually, if you're if you're not documentation kind of person, then you can refer Crypto Zombies. Okay, this one, Crypto zombies. Yeah, this one. Okay, this will give you an in-depth, very depth way of learning Solidity as well. Okay, but if you learn like all these basic stuff, then that's fine. You can read any contract, you understand the way the contract works, and you can write the contract as well. Okay, now let's see how to like deploy to Polygon chain or anything. How to deploy with MetaMask. So here, guys, MetaMask is a wallet. Okay, it's a wallet provider. Okay, EVM based Web3 wallet provider. So in order to let's say you're minting something, right? If you want to interact with the blockchain-based application from your browser should have Web3 support, and that Web3 support is actually possible by wallet like this. Okay, MetaMask, Coinbase, Wallet Connect. So all these, what they'll do is they'll inject Web3 object to your browser and lets you interact with the blockchain. Okay, now let me switch to Polygon testnet here. Okay, I'll show you how to add Polygon testnet and everything to your MetaMask tomorrow when we interact with hard hat and everything. But for now, I'll just briefly show you how to like interact with MetaMask. Okay, so I'm going to switch back to my account one, my primary account, and then here instead of Remix VM, I'm going to select injected provider. Remember, I told you it injects Web3. So I'm going to say Web3 injected Web3 provider. That is in my case, it's MetaMask, and it says custom network 8001. So 8001 is the network ID of Polygon testnet. Okay, and you can see this is my address. Right now, I don't have much address. I just have one address. That is this one. It ends with A1A, and you can see in my MetaMask as well, it ends with A1A. Okay, now if I deploy this, it's going to pop up. It will ask me for gas. You can see now. You guys can see this, right? Oh, okay. Wait. I didn't actually present everything, guys. Sorry. All right. Let me reject and try again. Let me reject this. Go back. All right. Click on deploy. It will pop up MetaMask now. Is my MetaMask visible now, guys? Can anyone confirm? Is it visible? I hope this is visible right now, right? It should be visible, the MetaMask pop-up. Okay. Now you can see here, right? It says contract deployment. So we're deploying a contract, and then it says unknown processing time. Remember I think in the first class I told you like Polygon takes a hell lot of time to process transaction. On testnet, on minute it's fine. On testnet it's insanely slow. So what we'll do is we'll click on edit, and we click on edit gas fee. We'll increase the gas to high. So now we can see it is likely to resolve in 15 seconds. So then we click on confirm. So once you do this, right, it is under pending, so it is processing. So let's wait until it is deployed. Oh, it is deployed right now. You can see it is deployed. So now, how can I visualize? How can I make sure it is actually deployed? So either you can come back here. Now you can see here it is actually working right now. It should work. So if I add a to-do right now, let's say Polygon testing, it will actually pop up my MetaMask for gas. You can see it will pop up my MetaMask again for gas. Remember, it didn't actually do earlier because we're using Remix VM. Remix was actually taking care of everything. Right now, since we're using MetaMask, it will ask us for gas. So I'm going to click edit again. I'm going to just click on high because we have to make sure that we complete this. Because if this thing goes to pending now, then it will be pending for more than 30 minutes. That's why. Let's give high gas fee. Make sure that it is pick up earlier. All right. So this should resolve pretty soon. Come on. Right, great. High gas fee paid off. Okay. So now we can see we were able to add a to-do. Okay. Now let's check in Explorer. Let's verify whether this was actually done or not. To do that, if you can copy this contract address. So you have this copy button, right? If you copy this, you get the address that is similar to the wallet address that you have. You can see here, it is actually similar to the wallet address. See, it is similar, right? But this is the contract address. Okay. So we go to Google and we type Polygon scan Mumbai. Okay, Polygon scan Mumbai. And then we go to the first link, something like this. Make sure you have Mumbai here. Okay, Mumbai. And then you just search your address, the address that you copied. So this will give you all the list. So you can see this was a deployment and this was add to do. So we just called a method add to do. So you can click on that. You can visually inspect it. So you can see it was successful and it was called by my address and for the contract, right? And this was the gas fee that was used. And if you scroll down, you can actually decode the input and see description string. The string was Polygon testing, right? That's what we sent, right? We can see all everything, right? So we paid the gas. The max gas was 3 kW. Oh, 3 kW is really low. I think Polygon is running on low gas fee right now. That's really great for us, to be honest. I was actually worried this won't actually work. I was actually thinking of using BSC testnet for now, just for this demo, but I just gave it a try, but it actually worked. That's cool. You can see it's 3 kW for gas and everything. This might not make any sense for you guys right now. I can totally understand that. But tomorrow, once we deploy NFT contract, right, you'll actually see this actually how these things will help you a lot to verify whether the transaction actually happened or not. Okay, right now there's not much information here. But tomorrow, once you mint an NFT or once you transfer an NFT, right, every single thing will appear here. So you can see how transparent is blockchain, how how every single transaction is available. Like you can actually see every single transaction that goes on. You can actually see everything. So you can we'll just look into that tomorrow. Okay, that tomorrow it will how you'll see how these things makes transaction really helpful for you guys. All right. So for now, okay, so let's end it here. So this was all the basic things that you guys need to know for blockchain, Solidity for tomorrow's class. So we'll come back again tomorrow. Tomorrow we'll see how to write NFT contract, how to deploy via hard hat, how to set up Web3 inside a React application, how to upload files to IPFS, and at the end, how to mint and then verify and then learn more about the transaction from this Polyscan. Okay. All right. So stopping the presentation. All right. Any question, guys? We'll try to let's have a Q&A session right now. Any question, you can drop it on chat or you can turn on your mic and talk to me, guys. Please share this code. Sure, I'll share this code. No problem.
Sir, can we learn directly Solidity?
Can you come again?
I mean to say, do we need to know
Yeah.
JavaScript or any other language before learning Solidity?
No. It's not like you need to know JavaScript or anything. It's fine. You can directly start with Solidity. That's fine.
Really?
Yeah. I mean, it uses some of the programming concepts as well. Isn't every programming language uses the same concept like arrays, numbers, and everything? So some things might be familiar to you. So you can directly start with Solidity. There's no issues.
Okay.
All right. What is the difference with storage versus memory in Solidity? So it's actually one of the way we define this. What do you say? This parameters in there. So memory, I mean, it's like a storage specifier that we use. So we use, I think there's also one more thing called index. So these are like, we usually use memory initially for every basic purposes, but index and everything, index and storage actually used for any complex computations. So we don't use event memory for event when we use string because we have to handle string properly. That's why event we don't need it. It's actually kind of easy to process on Solidity. Wait, let me share you one of the best read for this. I actually did go through this amazing thing that actually explains this even better. Memory and storage specifiers. Try to give this a read. It's actually amazing. Read on this one, the storage and memory. Enum and struct are used in commonly. Yes. It's not like used commonly in smart contract, but why we use structure nowadays is because after I think 7th version of compiler Solidity update, they reduce the number of parameters you can pass to a function. So I remember in Solidity version 5 or 4, you can pass more than 7 to 8 parameters to a function. There was no issues. But after 6th or 7th version of Solidity, you can only pass up to 3 to 4. That's it. If you pass more than 4, I think it will throw an error. So that's why people started using structure. So they define structure and then they pass that structure as a parameter. But structures are really used a lot. Yeah, that's true. Modifiers only work when you're writing and not reading. It might work for reading as well, but we usually don't add modifiers for reading because if you reading is for public, right? If you're reading, then it's a public data. We don't usually use modifiers for reading, but if you want, you can add it. Is mapping similar to JSON? Is mapping similar to that's actually, I don't know whether to say yes or no for that, but I think yes, because it follows key and value pairs. So actually yes. But I mean, instead of JSON, you can think map in JavaScript as well. We have this map in JavaScript, right? Something like hash map and everything. You can think something like that. Any other question, guys? View versus pure, what is the difference? As I told you, right? The view function, view and pure both are read only. Okay, that's the common thing. They both are read only. But pure function returns the same output. Anytime, any number of time you call the function, it returns the same output. And it doesn't depend on any other properties. Like let's say you have a variable on top of the function, like outside the function, it doesn't depend on that. Okay, and then it returns the same output every single time. That's pure. In view, you depend on many states outside the function, and then you return different output every single time, but it's a read-only function. That's why we call, that's the difference between pure and view on Solidity. Okay. One second. What if we want to change the function, then we have to delete it or make a new one. If we want to change the function, then we have to, as I told you, if you are updating the contract again, then yes, you have to deploy a new one. Once you deploy, you won't be able to modify that deployment. The reason is once you deploy a contract, right, it will be converted to opcode. Remember assembly language? You guys remember assembly language? I think some of you might have looked into that in your college. Maybe if you're in, I think third year or something, you might have that subject, right? If you're a assembly language. So this contract will be converted to opcodes that is similar to assembly language. So that opcodes will be deployed over there. So that's the reason you won't be able to modify that once you deploy a contract. You have to deploy a new one. Okay. Is it combination of Java and JavaScript? No. It's, I don't say it's a combination, but yeah, some syntax are similar. Some concepts and syntax are similar. Why we have to pay fee for deploying? Remember, I told you in the first day that the gas fee are nothing but the compensation for the computation fees of EVM. That's why. Because when you're deploying the contract is converted to opcode. It is being executed, right? If you have any constructor, it has to execute that constructor. It has to make sure that there is enough space available to you for your contract and everything, right? That's why we pay fee. Basically, we're using computation power of the EVM, so we are paying fee for that. And the miner as well, who will index all our updates, who will make sure the transaction hash is appearing for that contract, to make sure that address is appearing for that contract, who will add everything for the block as well. So we have to pay fee for them as well, right? So that's why we pay gas fee. I'm using AWS VPA price. Yes, we use pay gas to use EVM. Yes. No. Wait. No. When you use AWS, you pay the gas for computation fee, right? Yeah, it is actually kind of similar. So here you pay gas for EVM computation power as well as miner's effort as well, because miner is EVM, it just executes a contract, but miner is the one who indexes it, right? So let's say I deploy the contract, then he indexes it in such a way that my address deployed this contract with this transaction as he. That's how the indexing works. That's how the level of indexing that occurs, right? So that's why we pay gas for both miners effort as well as EVM computation power. Okay. Can smart contract be destroyed? Nope. You have to just take down the whole chain to destroy it. That's all. One small doubt. So who is owning the EVM? There's, as I told you, there's no single entity who owns the EVM. Okay, it's like group of people who's managing it. They won't own it; they are managing it. So if you're a miner, you can actually run your own version of EVM to execute the contracts and everything. So there nobody owns it. Many people manage it. Rule of miners. Yep. Gas fee depends on what? That's an amazing question, to be honest. So gas fee depends on many factors. The first thing is the current base fee on the block. So remember, right when we are right now we were in this Polygon Explorer, right? So the gas fee was really low. Remember, I was really surprised to see that it was 3 Gwei. So that is because of the network demand. So if there's a very high demand, then the gas fee rises up. If there's low demand, I mean, if there's a neutral transaction, then the gas fee comes down. That's the base gas fee. That's the first thing. And next thing is it depends on your priority. So remember, I was actually shifting to high gas fee in my MetaMask. That's the second step. Okay. And third thing is the complexity of your function. In our add to do, what we did, we just modified one data, right? We just modified the one mapping. So let's say you have around 50 mapping. You're modifying 50 mappings. So this complexity increases, right? So based on this as well, the gas fee increases. So it depends on all these factors. Okay. How to become a miner? It's very simple. You just have to have enough resources. You have to run Ethereum software, and then make sure you connect with all the peers. That's all. And that will cost you a lot because you need a hell lot of resources to run this mining system for Ethereum. But if you're considering, maybe it's actually a good try though. But you have to spend a lot of energy. And right now, since Ethereum is still on proof of work, you have to spend a lot of energy. But maybe if you are really interested, try after some September, because after September they are coming to proof of stake. They are merging their chain to proof of stake. So that will be a good time maybe to become a miner, in my opinion though. You're choosing environment for deploying and then multiple environments present. How to select which one is of which one to use? Okay. You can use anything for testing and everything. Actually, for this testing, I was using this Remix VM initially, and for while deploying the contracts for my for work and everything, we use different chains. So let's say we are working on Polygon, then I use Polygon testnet. Okay, if I'm working on Binance, then we use Binance testnet. So we just connect MetaMask for the remix, and inside MetaMask, we keep on changing the chains. That's all. Okay. Spend 4 to 5 lakhs. Maybe it might be 4 to 5 lakhs, or maybe more, or maybe less. Yeah, in tomorrow's class, will you show how to install Hardhat from scratch? Yeah, we'll be installing Hardhat. The first thing that we do tomorrow is we install Hardhat. We write an NFT contract. We test an NFT contract. We make sure everything is working fine. Only then we'll go to Web3 setup on React application. Okay. Why not remix? I'll tell you that tomorrow. Oh, sorry. Okay, wait. I told you that I'll be telling that at the end of the class, right? Exactly. Okay, sorry. So the thing is, you will have a lot of contracts when you're building application, right? You'll have a lot of contracts to deal with. So you'll have a main contract, then you have some utility contracts as well. Remember, when you're building a backend or a front end, you have have the components, and then you have some utility functions as well, right? Like helper functions. Similarly, we'll have some helpers as well. So it's very hard to manage on Remix all these stuff. So with Hardhat, we get many things. So we get when we are writing test cases, we get Hardhat runtime environment. It's like one of the function that allows us to run the contract inside the test case itself. Like you have Jest and Chai and Mocha, right? So Hardhat has this integration with Chai and Mocha that gives us a runtime, runtime utility to run all our test cases inside it. That's one of the amazing thing. Like we can directly execute our contracts, deploy, execute our contract inside test case itself. That's one of the things amazing with Hardhat, which Remix doesn't provide us. And next thing is it provides us with these plugins, which is very amazingly, insanely useful. To if you're dealing with multiple contracts, it helps you to define command line scripts where you can just run some yarn deploy to Mumbai, yarn deploy BSC, yarn deploy, and then it also helps you with these tags. So you can write some function, add some tags to it, and you can call the tag from the CLI. So it's really it will let increase your productivity a lot. You can directly invoke the contract, invoke the function from the CLI itself. It's very easy to invoke the function everything from CLI, right? I mean, if you're for the developers, it's really amazingly it makes everything easy through providing all the plugins and everything. And it also provides hardware config file, which is amazing. Like it's very easy to define. If you're working multiple chains, it's really easy. It makes it easy for you guys with hardware config file. So remix is like straightforward, right? It expects you to do all the work by yourself, but hardware provides you this many amazing tools to work if you're building context for the application purposes. CLI is command line interface, like your CMD, PowerShell, these stuff. Hard Hat is not like kind of special now. Actually, Trapper and Hard Hat, I think they do the same thing. Okay, there's different tools. That's all. So MetaMask Trapper is actually one of the tools that released from consensus, right? People who built MetaMask. So it's like it's not like Hard Hat is something that has upper hand right now. I mean, they both do the same stuff. Hardly they're different. They provide some other features. That's it. But actually, they both are really good. VS Code. No VS Code. It's just WebStorm. I really hate VS Code, to be honest. So I'll be using WebStorm throughout the session, this one in the future sessions as well. So you guys are free to use whatever tools you guys want, like VS Code or this one, Autumn or anything. Yeah, Dave and I, we both hate VS Code. Okay. And apart from IDEs, let's not let IDEs differ like things for us here. So let's keep IDEs aside. So apart from that, you guys are free to use anything you guys want, Atom or VS Code or Sublime or anything. It doesn't matter. Everything remains the same. If you just have Node installed on your system, that's done. No, no, no. As I told you, no need to install WebStorm. Okay, that's just my preference. If you guys are comfortable with VS Code, please use that. It's completely fine. Okay, just make sure you guys have this installed. Node, yeah. Make sure to have this installed. That's all. Node.js. I mean, npm yarn or something. If you guys have that, then that's fine. For students, use your college mail or email card if you want WebStorm for free for a year. Yep. You can get GitHub Student Pack and get it for a year. That's fine. That's true. You can get it for free for a year. I mean, don't. I mean, it's not like recommended, guys. Don't use WebStorm just because right now people we are talking about it. That's if you guys are comfortable with VS Code, then that's fine. Use one IDE. That's fine. Okay. All right. Any more questions, guys? How much time it takes to learn Solidity? There is no fixed time, to be honest. It all depends on the practice. Even I actually struggle to write some of the methods, parsing, and everything, even now. So it depends on practice, to be honest. Even now, even in my company, I'm actually asking them to like switch my position. Right now, I'm still in full stack most of the time. I hardly I get the blockchain work really less, like a contract to deal with the contracts and everything. So I'm actually asking them to reverse it. So there are few priority projects that's going on. So after them, I'll be switching to that. So hopefully I'll be like, involved with blockchain more. So it actually takes a lot of practice, guys, to be honest. You have to practice a lot. VS Code is deprecated. Yep. No, I mean, it's not deprecated though. I mean, I can agree with that. If you guys work with TypeScript, right? Here's my suggestion. If you guys work with TypeScript a lot, just try VS Code, WebStorm once, just once, like for 1 week, and tell me if you guys don't love it. Okay, WebStorm has an amazing integration with VS Code and with TypeScript. And if you guys use Git a lot, like resolve these merge conflicts, and if you guys review PRs a lot, then WebStorm has an amazing integration with Git as well. Just give it a try once. Okay. All right, guys. So let's end the session here. If you are a solid developer will you hire a solid from this session? No, 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 no. We won't. We're not actually hiring anyone. But if you guys are interested, maybe let me just share the link. Wait. Great. This is taking a lot of time to load now. Got it. If you guys are interested, maybe you can apply here. There are some jobs. I don't know whether we have Solidity developer. No, we don't have Solidity developer, but we have for Rust and Solana developer. So if you guys are interested, maybe you can try. Okay. All right, guys. So I've dropped the link on chat. Other than that, if you guys have any more doubts, you can join our Discord. You can. Thank you, Hari. Thank you so much. So you can join our Discord, ask any doubts with us. So we'll be online on Discord, so you can ping us anytime. So other than that, so if there's any question, again, pick us on Discord. We'll meet tomorrow. Tomorrow we'll start with NFTs. Okay. Bye. Thank you, everyone. Thank you so much. Thank you. Thank you for coming here.